So my talk was about a new technique that we developed called two-step fluorescence imaging. It has some similarities to multiphoton or two-photon excitation microscopy, except in that case you would normally rely on these expensive ultrafast lasers to produce the two-photon excitation. We use a probe which has two states, an active and inactive state, and requires two photon absorption events to be fluorescent. So that's why we call it two-step fluorescence. So the multiphoton imaging, that basically you get inherent optical sectioning, since most of the fluorescence will be produced in the focal plane of the objective. So the two-step fluorescence mimics that in many ways, in that you get most of the, if you collect the data under the right circumstances, you can get the two-photon like effect. So basically your fluorescence will be made inside the focus of the objective, and you don't have to deal with a lot of out-of-focus light. Well, so most of my lab works on developing these techniques for imaging, but we collaborate with many people, for instance, looking at the localization of specific Golgi apparatus enzymes. We're interested in where they lie in the pathway for the modification of proteins moving through the secretory pathway. We also have a collaborator that's interested in proteins and their localization and behaviors at the mitochondrial associated membrane complexes. These are areas where ER and mitochondria are associated in contact, and they're expected to be, or they've been shown to be involved in a lot of signaling and mitochondrial fission and fusion, etc.